In this module, let's talk a little bit about buffer overflows. Now, to make the case here, I want you to think about memory like an ice cube tray. Okay? What happens if you put too much water into a particular cube? Well, it overflows into another cube. Well, if each cube is a separate application or separate memory space, by manipulating one cube, you overflow or manipulate the integrity of another application. So let's take a little bit closer look at some basic concepts of buffer overflow. Well, we just talked about the analogy of the ice cube tray. What you can do is put a boundary check on what gets stored in memory. And if you actually set the boundaries, well, then you decrease the likelihood of actually overflowing into another section of memory. You have to watch your commands like string copy, right? Because this is where we say, go get something, copy it, and put it somewhere else, and we move the memory around, okay, in terms of heaps and stacks. Also, you got programming vulnerabilities in themselves. So whether you're using C or C++ or whatever the programming language is, there are certain vulnerabilities within the way that the programming languages work within themselves. So just knowing that, if you can use better programming languages to actually achieve your objective, that's ultimately going to be the better route. Also, security guys are not necessarily programmers, and programmers aren't necessarily security guys. More so, very few security people or programs are actually pen testers. So this is definitely a specialized field of penetration testing. Okay, you typically can break pen testers down into some basic areas like network pen testers or programming pen testers or wireless pen testers, where these security pen testers or software pen testers are definitely a bird of they're definitely unique. Okay. Plus, you should also understand the stacks, the concepts like last in, first out, or first in, first out, right? This is the way that memory gets stored. So if you understand that, well, then you can manipulate an application to take advantage of that. Next, heaps. This is your dynamic memory, and we can use code like, I call it malicious location, but it's actually memory allocation. Okay, but if it's done wrong, well, then it could be a malicious location. But it's how do things dynamically get stored in RAM. For example, let's say an application, you put some input or some data into a field and it has to temporarily store that in memory. Well, it's going to use the heap portion to dynamically allocate that. Also, the concepts of pushing and popping. The best example of push and pop that I ever I've heard is basically, if you've ever been to like a McDonald's or something like that where they have the stack of cups, right? This also gets tied into the last in is the first out. You take that stack of cups and you basically slide it in. So the last one in is basically the first one out. And that's how memory can get stored into the stack in terms of pushing and popping. Also, you can use the analogy of a champagne bottle. You push it in or pop it out. Other ways you can do that. But as we look at some of the tools, we definitely will pay close attention to the extended information pointer, the stack pointer, and the base pointers, because this is where the programming languages get their next instruction set as they actually process the code. Also, we've talked briefly before about shell code or even polymorphic shell code. Well, in the concept of programming languages, shell code is code that specifically relates to an exploit. So as you send the shell code over to get executed, if it changes the stack or performs a specific exploit like a buffer overflow, well, then that shell code can also be malicious. Then you have null operators, or sometimes these are called no ops or noops even, depending on how it's written. It's written in a ton of different ways, but NOP should work just fine for our purposes. In hex, you could do the 0x90 as well, but it's basically a null operator or filling the stack with all nulls to bypass an instruction set, therefore manipulating where the next instruction set actually comes in. And then there's also the concept of smashing the stack, which is just layman's terms for creating a buffer overflow. So when we look at some of the hands-on examples, we're going to look at tools like Ollie and heap.exe and things like that. There's a handful of tools here that we can use to get the basic idea of how to manipulate memory and buffers and some programming language compiler techniques, and how to get information out of executables like bin text and things like that. So we'll look at a handful of the tools, but realistically, like I said, this is in its own field. So basically, let's look at some countermeasures. Okay, what would you do to stop the penetration tester? Now again, this is high level, so one thing I would highly recommend is actually manually check the code in itself. Typically, we try to rush things to market. So you get programmers to develop stuff, but they don't necessarily look at the security aspects of that. So there's really no really good manual auditing of the code. You may have heard a developer say, hey, great, that works. But very rarely will you hear a developer go, hey, great, that's secure. Okay? They think in terms of functionality, not necessarily security. So when you manually audit the code, also do it for security, not just functionality. Use good compilers or safe compilers, safer library support, depending on what programming your language you're using. Disable stack execution, if at all possible. Use runtime checking so that when the application runs, it gets checked. Design the application with security in mind, not just functionality. You can use things like stack guards, which as the executable is running, it detects like a buffer overflow and therefore stops it or prevents it. It's kind of like an intrusion prevention software for, executables, if you will. Also, restrict certain components of code or certain uses of it, like gets and string copy or malloc or whatever the programming objective is you're trying to achieve. There are certain things that you should restrict from using more so than others, or at least put a boundary check on them. And then if you're from the Windows land, you could use something like data execution prevention, which is really just a turn it on or turn it off component. So in this module, we talk about the basics of buffer overflows, and we'll talk about some tools and how to analyze this. We'll use some stack analysis tools, and we'll use Ollie, and we'll get the basics. But this is definitely its own field outside of the scope of traditional network penetration testing, where we focus on scanning and ports and exploits and wireless and things like that. So let's go ahead and take a look at some hands-on examples.